Okay, so this particular session, we have broken down into two. Actually, I would have preferred if we could do this hands-on, because then I can work with you all better. But unfortunately, the situation is such that we'll have to do it online. Initially today, what I will do is I will try to give you some understanding about what is a meta-analysis, very basics. I know that there will be a sort of a different crowd at this forum where some people may have already done meta-analysis. But here, for the purpose of this presentation, I'm assuming that most of you are new to this area, so that I'll be start training you all with the very basics, right? So initially, once you do that, during tomorrow's session, we will look at how to handle this software Rev-Man, which is now for meta-analysis. Of course, it is a statistical analysis, right? So you need a software to do the statistics. So there are many softwares available, which I will tell you, but Rev-Man is a fairly easy to use, freely available software. I hope you got the link that I sent and you were able to download and install it, right? So that is the outline of what I will be doing during these 2 days. In between the session, you can ask any questions, interrupt me at any time and ask any questions and clarifications. If you are not clear about a particular area, you can stop me and ask. In addition to that, you are welcome to send questions in the chat as well. No issues, right? Okay. So during today's session, what we will look at is basically what we mean by a meta-analysis. Of course, I'm starting with the assumption that you all have already had some training. According to what I spoke when I spoke to Sandharuban, he said that you all have already had some training on doing a systematic review. So I am starting this particular session based on the assumption that you have already had that training, because meta-analysis is an extension of a systematic review, right? So you need to know what a systematic review is, how to conduct a systematic review, the basis of the literature search, how we do that, how articles are selected, and so on. The meta-analysis is the statistical part of the systematic review process, right? Then we will look at why we do a meta-analysis, and then finally, to answer the most important question, how to do a meta-analysis, right? So what is a meta-analysis, right? So basically, this is the definition of a meta-analysis. A meta-analysis is a method to quantitatively combine different research that are answering the same question, right? If I take from my own personal experience, let's say, which I will be referring to, we did a clinical trial on the effect of zinc supplementation in pre-diabetes. Let's say it's diabetes. So then we have done one project in Sri Lanka. There is another project that had been done in India, another one in Bangladesh, right? So we all have come up with different estimates for the glycemic control, fasting blood sugar, HbA1c, right? Okay, so a meta-analysis is essentially where you take those outcomes from these different trials and pool them together so that you have a quantitative value, right? If you do a systematic review alone, you will not have this quantitative value, right? So what the meta-analysis gives is it gives you a quantitative value. For example, at the end of the meta-analysis, you would be able to say, zinc supplementation reduces blood glucose by X amount. For example, if you have entered the data in milligrams per deciliter, at the end of the meta-analysis, you will be able to say zinc supplementation reduces, or maybe does not reduce, whatever, blood glucose by, let's say, 20 milligrams per deciliter, right? That is not the only thing. You can go further and say whether this reduction is significant or not, right? Meta-analysis will give you a p-value, which you can tell whether the difference is significant or not. So it gives you a quantitative estimate, but remember, the process of combining the meta-analysis results are only valid as it is only good as your literature search. So a meta-analysis always needs a good systematic review, right? So because you are combining studies that are similar in nature. Now, for example, you cannot combine, that is obvious, you cannot combine fasting blood sugar with postprandial. You cannot combine human trials with animal trial data, right? You cannot combine. Now, ideally, when you are using zinc and let's say blood sugar reduction in diabetes, if you are combining multivitamin supplements, then of course you may not get the best results, right? So likewise, your systematic search process needs to be very good. You need to select articles that are answering the same question, right? So what I'm trying to tell you is your meta-analysis results is only good as how good you have selected the article. So you cannot replace a good systematic review, right? So that is the starting point of a meta-analysis. A meta-analysis always has a good systematic review that is accompanying the meta-analysis. You combine so this is the type of secondary data analysis. So that is another advantage of conducting both systematic reviews and meta-analysis. You don't have to get approval from ethics review committee. So this is a good way of doing research, and you can do it at home. You can sit down in your computer, provided you know how to search the literature and has access to these different databases. You can conduct the research online, right? So these are some of the important advantages of systematic reviews and meta-analysis, right? So the systematically you are combining the study, so you will obviously see an advantage. Even this particular, let's say the zinc clinical trial that we did, we only selected 200 clinical participants, right? So, but let's say you are combining the zinc project, Sri Lanka, India, Bangladesh, each of these studies will have 200, 300 maybe participants. So you are increasing the number of data points, which will obviously increase the validity of the results. We always know that the power or the validity, the conclusions are always valid if the sample sizes are higher. Higher the sample size, higher the power of the conclusions. So a meta-analysis will give you that kind of powerful data, and that is why when you consider the evidence pyramid, we are all familiar with this. When you consider the evidence pyramid, the meta-analysis and the systematic reviews are sitting at the top, right? Because that is where it gives you the best evidence, right? Not only a single clinical trial. Now we all know even how well a trial is conducted. Generally, for new medicines, a single clinical trial is not accepted for registration. You need at least a couple of clinical trials, right? That is because even though you have the best trial design, clinical trials are subject to a lot of bias. However you try to minimize it, trials are conducted in a controlled environment. There are a lot of problems, and the data sample size points are minimized, less. So that is why a single trial will not give sufficient evidence. But when you combine the data using a systematic review and meta-analysis, this is what will finally come in the guidelines, right? So by using the meta-analysis, we can say, for example, I'm referring to diabetes frequently. Sorry if you are not familiar with that, because I'm familiar with it. I hope everybody knows diabetes. So it is by meta-analysis we can say, for example, metformin reduces HbA1c by 1% or something like that. So not from a single, of course, single clinical trial can also say, but the power of that results is not good, right? So meta-analysis is the one that gives us the highest level of evidence, right? Right. So let's compare these different types of reviews. On one hand, you have what is called the traditional review. We sometimes call it the narrative review, right? Then you have what we call the systematic review. I'm sure you have gone through a couple of training programs on systematic reviews. You are aware about it. And the extension of a systematic review is a meta-analysis. Now, if you look at the authors in a traditional review, most of the time it is written by an expert in that field. Maybe one expert, maybe two experts, right? So it is mainly based on the expert's knowledge. The search process is not systematic. I will only select articles that I am aware about, so that there is no systematic nature to that. Search strategy is individual based, according to the author's judgment, right? Even the conclusions then obviously will be biased depending on the author's judgment and the set of articles that have been included, right? But when you go into the process of a systematic review, you have a team now, right? So if I am conducting a systematic review on a zinc supplementation, let's say for diabetes, I will probably have on my team an expert on systematic reviews and meta-analysis, maybe a statistician if I am planning advanced meta-analysis techniques, right? Which I will tell you in shortly. Maybe an endocrinologist, right? Or a physician who has expertise in that area, because you will see there are several things in the systematic review process where you require expert knowledge, right? I will train you. Even the meta-analysis requires some expert knowledge. For example, me coming from a background of general medicine or MD medicine, I will not be considered an expert to answer a question for a systematic review on pediatrics, for example, right? Because the expert knowledge is required to generate the questions, to decide on the outcomes, to decide on the inclusion and exclusion criteria for a systematic review, because the process is systematic. The systematic process is what leads to the meta-analysis. You have to understand that. So nowadays, people have gone even further, where systematic review protocols are now published. Now, earlier we know when you talk about clinical trials, when you talk about research, there was a place where people could publish the research protocol. People could publish the trial protocol. Nowadays, people can even publish systematic review protocols. Right? Systematic review and meta-analysis protocols are also accepted for publication. So there is a very well-defined structured protocol. Why is a structured protocol important? Obviously, because then only the answer is going to be valid. And if somebody else will repeat the search according to your criteria, they should end up with the same results, right? If another group of experts decides, okay, I want to answer the same question, I will follow the same search strategy, I will search the same databases, I will have the same inclusion exclusion criteria, their findings should be matching your findings. They should not be very much deviant. Obviously, you will understand when you practically conduct systematic reviews and meta-analysis, there is a subjective component, but we are making this process systematic to minimize that subjective component. It is because of the subjective component that you require experts, right? Otherwise, the subjective opinions will not be valid. You will understand this when you start conducting systematic reviews, where the subjective parts come into play, right? But the main difference between systematic reviews and meta-analysis is that in a systematic review, you can only give a qualitative conclusion. You cannot give a quantitative conclusion. You can, for example, say zinc supplementation reduces blood sugar, okay, which was seen in 3 clinical trials, and the range of reduction was between 20 to 30 milligrams per deciliter. You cannot give a single figure by combining the data. Systematic reviews, you cannot do that. It is only by doing a meta-analysis you will get a summary value for that conclusion, right? Okay. So this is 2 examples answering the same question. Taking the traditional drug metformin for the treatment of diabetes, right? Okay. So here on top, you have what we call a systematic review, right? Which is published fairly in 2013, metformin, and also talking about metformin in diabetes. So obviously out of these 2 articles, this is the one that will generate the highest level of evidence. Of course, this is a little old article comparatively, and you may, when you look at this, you may see that this particular article has received about 200 citations. This particular article, I know, because although it's not visible, has received a lesser number. The reason being, this particular article, actually the original article was in a different language, so that also affects the citation, right? So however, if you look at the accuracy or the validity of data, it is the data coming from this article that has more power, because it is combining and doing a meta-analysis rather than data coming from a systematic review alone, right? But it is, you will have there will be systematic reviews alone, and there will be systematic reviews and meta-analysis when you are answering the same question. But if you are doing a literature review, I would advise you to base your conclusions on a meta-analysis rather than basing your conclusions on a systematic review, right? Because that has a more accurate data. But obviously, you need to look at the date. Now, you will have more findings here from this 2013 systematic review, because obviously there will be more trials here rather than there will be trials here, because this is 2005. So that is also something you need to consider when looking at. So you will see sometimes on the same questions, there are systematic reviews and meta-analysis every 5 years. That is because new data is generated. Now, we did a systematic review and meta-analysis on coconut oil, right? So there was another systematic review on coconut oil, which was published about 2 years ago. Why did we do another one and replicate, and why did the journal accept it for publication? Because during that time period, there were new clinical trials, new evidence. So then there is a reason for you to combine the data and relook at it again, right? Okay. So on the same topic, you will have several meta-analysis coming from different years, right? But obviously, before doing a meta-analysis, better to check if there has been a meta-analysis on the same topic very recently. It is unlikely the journal will accept your article after all your tiresome search process, because they will say, look here, there is a meta-analysis that has been published last year, and during last year and this year, there are no new clinical trials. So we don't see the reason why you need to do another meta-analysis. So just make sure before you are starting that you search the literature and see whether there are existing meta-analysis, right? And I hope during the systematic review training, you learned about the Prospero database, where people published their plans for doing systematic reviews and meta-analysis, right? So this is obvious. The number of meta-analysis is increasing throughout the years, because more evidence is being generated from more clinical trials. So more people are combining data. So obviously the number of meta-analysis will be going up year on then, right? Now then, a question might arise to you: why do we need a statistical software? If we know the sample size, if we know the mean values, can't we simply add everything together and come with a pooled mean? Why can't we do that, right? Why do we need a software, right? Let's look at this particular data set. Now, this is a forest plot. This is the output that I will train you further down the line about what the forest plot is and its different components. But just imagine, now this is a meta-analysis where they have looked at the death at end of follow-up when corticosteroids are given for brain injury. So these are individual studies that have looked at this outcome, individual studies, right? On this side, you have the number of subjects and the total where corticosteroids have been given, and on the other side, the placebo, right? So you see the number of subjects, the total, the number, and they have combined, right? Death is the outcome they have looked at. Number of subjects died in this group versus the total in that group. Number of subjects died in this group versus the total in this group. Now this is now here at the bottom, you have a simple arithmetic addition. You add these numbers here and come with 410. You add these numbers here and come with 1194. And similarly on this side, you add. If you have that particular data, for each side, you can combine. And you can see 34.3% on this side and 32.5% on this side. Based on these two values, you can calculate the relative risk, right? If you do that particular calculation, you will see then relative risk is higher than 1. Then your conclusion will be there will be a higher death rate in the steroid group, because the relative risk is higher than 1, greater than 1, right? If you simply add these together. On this side, you will see the meta-analyzed relative risk, the pooled value, right? So the pooled relative risk is 0.96 from the meta-analysis. Why? Because then that means the steroid groups, the death rate is lower, right? Why is the pooled value different from the crude estimate? It is because the meta-analysis gives a weight. It allocates a weight to the different studies. Now here, the weight is depending on the size of the study. Obviously, when the size of the study is large, those studies are likely to be more accurate rather than smaller studies. So this total weight is taken as 100 and then it is proportionately allocated in the weight. So it gives a weighted average. The value that you get here is not a crude value, it is a weighted average. Weighted average. That is the difference, right? And that is why you need a statistical software to do this, right? Okay. So yeah, so that is why we talk about meta-analysis and the statistics in meta-analysis and the importance of a good statistical software to do this, right? So again, coming back to the question of meta-analysis. So now you know it is a research where you combine multiple studies. Importantly, multiple studies answering the same question, right? If you combine multiple studies that are heterogeneous in nature, I will talk about heterogeneity in the future, in the next few slides. If you combine studies that are heterogeneous in nature, you are not going to get a valid answer to your question. So you have to ensure that your inclusion, exclusion criteria and your search strategy is matching the research question. That is where the system, again, I am telling you the importance of a good systematic review. The statistical software will give you a pooled estimate, which is a weighted average, right? Based on the sample sizes and the variance, right? Okay. There are different methods to give this weightage. I will briefly tell you this. There are different models. We call it meta-analysis models, right? I will show that to you in the next few slides. So what is the advantage of doing a meta-analysis? You obviously know that the advantage from the research point of view is that it provides a pooled estimate, which obviously increase the power and the precision of the conclusion, right? When you combine the data, number of data points will increase. The higher the number of data points, the more powerful the conclusion and more precise the conclusion, right? So that is an advantage for research. Then another advantage is you can generalize the results to a larger population. Because let's say, for example, I do a research project here, zinc supplementation for diabetes. Okay, people might argue, your conclusions are only valid for South Asians because you have done it in a South Asian population. We know genetically South Asians are different, right? Okay, fine. Then I go another step and do a meta-analysis where I combine studies answering the same question, zinc supplementation for diabetes. Now I combine studies from Europe. Now I combine studies from Africa. So then you can generalize your results, right? So that is another advantage. You can develop and refine and test hypotheses. There is something called subgroup analysis in a meta-analysis. I will show you how that is done, where you look at subgroups. Now, for example, you look at zinc supplementation and diabetes, right? You have 20 studies. Then you want to see, okay, now I will look at zinc supplementation and diabetes only in the group that is having diabetic nephropathy. That is a subgroup analysis, right? So you can test new hypotheses. Is zinc effective in all diabetics? Is zinc effective in only in patients with diabetic nephropathy? Then you can subgroup the different doses. One study may have used 20 milligrams, another study may have used 40 milligrams. You can compare the two. Is 20 milligrams or 40 milligrams more effective than 20 milligrams? Because then you can combine the studies with the 20 milligram. They may reduce blood sugar by 10 milligrams per deciliter. You can combine the studies only looking at 40 milligram. They may reduce blood sugar by let's say 30 milligrams. So then you can conclude 40 milligrams of zinc is better than 20 milligrams. So likewise, you can develop, refine and test these hypotheses, right? It reduces the subjectivity, obviously. Systematic reviews, again, sometimes the conclusions can be subjective, right? it's better than traditional narrative reviews, but it sometimes can be subjective, but systematic meta-analysis will reduce that, right? And it provides a chance for you to collaborate. Right? Now, we have done systematic reviews in Sri Lanka. Now, for example, there was a systematic review we did. I did together with Professor Anil Jayawardena, where we looked at alcohol and alcohol-related hangover products and their effectiveness, right? Their effectiveness. How effective are these products to treat hangover after consuming alcohol? That was our question, right? There was so then for this project we were not experts in the area, right? So then we invited the gentleman from Europe who had done many research projects on many individual clinical trials on alcohol hangover, right? We invited him on board and as an expert. We have never seen him to date. We haven't met him, but still we have published this research paper and his inputs were very valuable for us to design the project. So people are willing to collaborate and you don't need to physically meet them. You don't need to go there. This is not like lab research. You don't need to go to that university. It's a good opportunity for you to collaborate with foreign institutions. And another advantage coming from Sri Lanka in conducting systematic reviews and meta-analysis is because we can do it at home. We know how limited our funding are when we want to conduct original research. Now I can tell you an example. There was a clinical trial we designed to test a new drug for COVID, right? COVID. It's a internationally important thing. But to date, we have not received funds for that. We applied for the grant in February, March. Trial, everything approved, ethics approval, everything taken. Now we can't conduct the study because we don't have funding. So however good your idea is, in Sri Lanka, you cannot do good original research because the funding is limited. You cannot do good clinical trials. It's a very big problem unless it is internationally funded. This is an opportunity where you can do good research. Nowadays, the descriptive cross-sectional studies we do, the observational studies we do, the big journals do not accept because everybody has done those. They are asking, why are you doing this? And when we tell them, okay, we are doing this because this has not been done in South Asia, they will show you a publication from India. So nowadays, because of that, we cannot publish in top-end journals because we don't do high-quality research. We don't have funding. That is, I'm not saying we are not doing entirely, but that is limited, you know. But systematic reviews and meta-analysis is a place where you can compete internationally and publish even at the top journals, right? Provided you answer a very pertinent and important question, even Lancet will be willing to accept your systematic review and meta-analysis. Whereas our cross-sectional studies will never get published in Lancet, right? Okay, so it's another good opportunity for us as Sri Lankans, right? So during the next part of my discussion, I will base this on this particular one, taking it as an example, zinc supplementation in diabetes. This is a review that is a very old one, even when they showed the profile there. And the other important thing about systematic reviews for people from the university community, this generates lots of citations. If you look now, when Dr. Roshini was speaking, they showed my profile. You will see the top 3 or 4 articles are systematic reviews, citations, right? So this generates a lot of citations, provided you do something on a very important or relevant topic, right? So this is something we did in 2012, and I will base this. The question that we are trying to answer here is zinc supplementation effective in glycemic control in patients with diabetes mellitus, right? Okay. Right. Now, this is the process of conducting a meta-analysis. I will be skipping the first 3 steps, which I presume you have already had training when you did the one on systematic reviews. So the PICO model is a place where you can develop the research question or the hypothesis, not only limited to systematic reviews, right? So it looks at the patient, intervention, comparator, and outcome. So in this particular one, the patient population is the patients with type 2 diabetes. Intervention is zinc supplementation. Comparator, based on this title, you can't say what the comparator is, but I will tell you in here, we compare this against the placebo, right? What is the outcome evaluated? Again, based on this title, you can't say what is the outcome, but we looked mainly at the glycemic outcomes, right? Okay. So that is a good way for you to look at the research question, right? I will just refresh. So then you have to develop the search keywords and search the literature. You are better to search the literature in several databases. PubMed, everybody has access. I don't know whether you have access to Scopus at Eastern University because the access is limited. We do have access at the faculty, our faculty. And then the other good website, the search database to search for medical literature is the Web of Science. Those three are the main three databases: PubMed, Scopus, and Web of Science. Of course, for Web of Science and Scopus, the access is limited. Web of Science, I know Jayawardhanapura University has. Scopus access is available at the National Science Foundation and at our faculty. Of course, PubMed is available to all, right? So once you do that, you select the articles based on the inclusion and exclusion criteria. Before you proceed, you need to do an assessment of the quality.